Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to write electron configurations for transition metals. So transition metals have a lot of exceptions because the D sublevels and the S sublevels tend to be closer at higher energy levels, and so sometimes there's exceptions to the rule. I'm going to go through how you are going to generally figure out what the electron configuration for the ground state of a transition element is, both the neutral and the ion as well. Okay, so one of the things you want to keep in mind for the ions is that because of the close energy level between the S and the D sublevels, it is quite common that the S sublevel electrons will be removed first, followed by the D when you're forming your ions. So that's going to come in handy when you're trying to write your electron configurations. In this video, I'm going to do the shorthand way just to save time. So we're going to use the noble gases in square brackets. So let's start with number one. So we have zirconium. So we're going to have to look up in the periodic table the noble gas that comes just before Zr. Okay, so Zr, okay, that's going to be krypton. So we're going to start with Kr in square brackets. And then we're going to look to see what sublevels are used for this element in their electron configuration. So if you look up again Zr is number 40 in the periodic table. So it's going to use the S and the D sublevel. Okay, so it's in period 2, so it's going to be using the 5S and the 4D. So we're going to have 5S and 4D. Okay, so how many electrons does zirconium have above or beyond krypton? So that would be 4. So it's four more electrons than krypton. So we're going to have to put 4 in here. So 2 are going to go in the S sublevel first, and then what's left over goes into the D. So we have 5S2, 4D2. And so that is the electron configuration for Zr. All right, what about cobalt 3+? So we got cobalt 3+. So how do we write the electron configuration for that, the ground state electron configuration? So we're going to follow the same thing. So if we look on our periodic table for cobalt, CO, cobalt is in the 4th period, and it follows argon. Okay, so we're going to have to write down AR. So we're going to write down AR in square brackets. It has how many more electrons beyond argon? That's going to be, if we look, we're going from argon, which is number 18, to cobalt, which is 27. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 more electrons. So it's going to go through, since it's in period 4, it's going to go through the 4S sublevel and the 3D sublevel. We've got 9 extra electrons, so we got to put the first 2 in the S sublevel, and then we have 7 left over. So we're going to put that there as well. But this is assuming a neutral atom. We got a 3+ charge. That means we lost 3 electrons. We have to subtract 3. The rule is the 3 that are taken out, you first take them from the S sublevel, and then you take them from the D. So the last electrons to be added are not the first electrons to be taken away. So we're going to remove 2 from the S, and then we got 1 more to remove, so we're going to remove 1 from the D. That's going to give us a 6 and a 0 there. Now, you can write it like this. A lot of times what they'll do is they'll just drop the 4S since there's no electrons. And so they will write it like this: AR in square brackets followed by 3D6. I've seen it both ways, so but this is probably the better way here. So this would be the electron configuration, the ground state electron configuration for cobalt 3+. Okay, what about OS? Got to look up OS. OS is number 76 on the periodic table. It's in period 6. So here we're going to have, so the noble gas that comes before OS is going to be Xe. So here we're going to have square brackets Xe, xenon, and then it's going to go through what sublevels is it going to go through? It's going to go through the S, the F, and the D. So it's in period 6. So that means it's going to be 6S, and then it's going to be 4F, and it's going to be 5D. So those are the sublevels. How many electrons do we have beyond Xe? We gotta go through the transition elements. That's our F. So when we count that, also if we look at the number, the atomic number, that will also tell us. So the atomic number is 54 for xenon, and for OS it's 76. So that's 22 more electrons for the neutral atom. So 22 more electrons. So we're going to put 2 here for the S. We got 20 left. We got 14 to fill, so we're going to put 14 for the F. So that's a total of 16. 22, we have, so 16, 22 minus 16 gives us 6. So we're going to have 6 left electrons there. So here we got 6 plus 14 gives us 20, plus 2 gives us 22. So this is the ground state electron configuration for OS. Okay, now what about NB2+? So again, we're going to look up NB on our periodic table. NB, where's NB? NB, not finding, there it is, number 41. It's in period number 5. So 41, period number 5, and the noble gas that came before is Kr. So we're going to have Kr in parentheses. And again, NB is in the 5th period, number 41. So it's going to go through the S and the D. So 5th period, so it's going to be 5S, 4D. And the number of electrons beyond krypton, that's going to be, if we look at krypton, going from 36 to 41, that's going to be 5 extra electrons. So we're going to put 2 here and then 3 there. But notice we have a 2 plus there, so we lost 2 electrons. So we're going to have to remove them from the S first. So that's going to be 0. So that means the electron configuration is Kr in square brackets 4D3. Again, a lot of times you'll see it like this. A lot of times you'll see it like this. It's probably better this way since this is actually empty. There's no electrons in there. But it does actually still exist. That energy level is still there. Okay, so that's how you write the electron configurations for your transition elements. Be aware of the exceptions, like because of the fact that the half-filled D sublevel, and the full D sublevel is more stable than not having a half full or full sublevel. So sometimes if you've got 2 electrons already in the D if you already have 4 electrons already in the D sublevel and you've got 2 in the S, one of those 2 electrons could jump up to fill in a half full D sublevel. And the same thing with the full. So you could have an S electron jump up to the D sublevel to make it a full D sublevel. So there are those exceptions, there are other exceptions, but this is what we look at. This is the ground state electron configuration. This is how you figure it out. I hope you found this helpful. If you like this video, please like, share, subscribe, hit the notification bell, put a comment in the comment section. Thanks for joining me. I'll see you next time.